Alrighty, everyone, welcome to day 6 of Advent to Code. Here's hoping today we can finally get back on track, not make more dumb mistakes, get our code going well. Here's hoping. These past few ones haven't been too bad, they've just dumb mistakes, they've really been killing me, but at any rate, code again, all blank is all set up. Both these files here, so I'll dump our input into here and get started. 3, 2, 1. Day 6, let's go. Grab a puzzle input real quick. Dump it into here. I didn't mean to close that, but okay. Alright, C4 is getting steeper. Maybe the sleigh keys got carried this way. A massive school of glowing lanternfish swim past. They must spawn quickly to reach such large numbers, maybe exponentially quick. You should model the growth rate to be sure. Although you know nothing about the specific species of lanternfish, you make some guesses about their attributes. Surely each lanternfish creates a new lanternfish once every 7 days. However, this process isn't necessarily synchronized between every lanternfish. One lanternfish might have 2 days left until it creates. Yeah, okay. So you can model. Furthermore, you reason a new lanternfish would surely need slightly longer before it's capable of producing more lanternfish. 2 more days for its first cycle. Okay, so there's a bunch of rules. Lanternfish initial timer value 3. After 1 day, its initial timer 2, 1, okay, 0. Internal time will reset to 6, and it would create a new lanternfish with an internal timer of 8. Okay. Lanternfish that creates a new fish resets the timer to 6, not 7, because, wait. Because 0 is included in valid timer value. Yeah, okay. The new lanternfish starts with an internal timer of 8, does not start counting down until the next day. Realizing that you're trying to do submarine produces a list of ages, several hundred nearby lanternfish. Inputs, okay. The first fish internal timer of 3, the second fish internal timer of 4. Okay, produces the following. Each day a 0 becomes a 6 and can add a new 8 to the end of the list. Okay. The lanternfish would be it for 80 days. Okay, so we have to go through this process and compute. Okay. So first things first, we're going to need. Oh boy, where to start with this one? So basically, we're going through those numbers. We're just counting down. Okay, so actually, this isn't too bad. What we're going to do is we're going to make a list of integers here, and we're going to do. This is going to be the life, I guess, or this is going to be the fish, I guess. We'll do inputs. There's just one line, right? I shouldn't close this. There's just one line, yeah. So grab 0, go ahead and split on commas. We're gonna use stream here just because. No. I'm gonna do this a long way. Just to do this kind of a bit quicker, I guess. String S. Fish add integer parseInt S. Just go with that. Okay, so now we have our fish here all in integer form. So we need to go loop iterates over all these, and we need to go for after 80 days. So we needed to for int day equals 0 while day is less than 80. Day plus plus. So go through all the days. And then for each day, we need to go through all the fish and decrement their values. If it's a 0, we need to do some special logic and continue from there. So now what we'll do is we'll go through all of the fish, fish life, I guess, in fish, and we will be adding to this. We won't be, let's just go backwards just to be safe. We're not going to remove any, so it's just fine, but we're going to go backwards just to be against safe. -1, while I is greater than or equal to 0, I minus minus. And so the fish life will be equal to fish get, whoops, I. Alright, so we're going to do, first we're going to do, well, we'll do just some logic here. So if the fish life is greater than 0, go ahead and just decrement it. Nothing to do, all good there. Else if the fish life is 0, we have some special logic to do here, because we will then, oh, we actually have to update this, sorry. Fish set I to be fish life -1, sorry. Right, we had to do that because we're actually updating the value in the list. So if it's 0, it creates a new one at 6, but it resets itself to 6. So reset itself to 6, and then we should do fish add an 8. Right? And that's it. Yes. Okay. Wait, is that it? And then just do a lap of fish.size? Wait, is that really it? No. No way, that's it. Oh, that was it. Okay. 835, not bad. Part 2, live forever and have unlimited food and space, where they take over entire ocean after 256 days. After 256 days. Okay, so then just change this to 256 and run. Oh no. Huh. This is just taking a second. This is really taking a second. Goodness. So actually, there's a way you can improve this. While it's going, I'm going to improve this. So what we're actually going to do is we're going to instead have a hash map here. And you're going to have integer and integer. And new map. Do is instead, oh sorry, this is a map, this is a hash map. What we're instead going to do is we're going to do fish put so it's going to be this, and then it's going to be fish dot get or defaults of this, and then 1. So what we're gonna do is we're gonna use this hash map here to basically keep track of how many fish are at each stage of its life. Because again, they're all changing the same way. So that way we can have like, there is 5 fish at 3 days left. Those 5 fish are all going to go down to 2 at the same time, and we won't have this error we're going to get out of memory. Okay, not a bad idea. So that's fine there. And so what we'll do here is we'll actually not go through all these fish. What we're actually going to do is move all these fish around. So for key, so for int key in fish dot key set, we're gonna just make a new one is what we're gonna do. This is kind of copy, it's kind of weird, but this is gonna be the easiest. I could just shuffle them around, but I'm not gonna worry about that. We're just gonna do it this way because again, it's not ordered. I could do it better, but no, let's just go ahead and do it the fine way. So since we know each day, we're gonna start at 0, and we're gonna shift. But if we shift, then we're gonna have the problem with 8. Let's just copy. We're just make a copy. This is fine. They could do this a little bit better, but we're gonna make a copy. So we're gonna go ahead and do copy.put, and we're gonna do key -1, and then fish dot get key. So this will then take all the fish at a certain day and move them to 1 less. And then we can go ahead and do all this logic again for this check here. Fish life isn't key is the fish life, so I guess we'll do fish life. This is the key. And then so if it's greater than 0, yeah, just go ahead and do that. Otherwise, if it is 0, we're going to put this to 6 because this is the 0 column, so we'll go to 6. And then we're also going to do a copy, and we're going to put at 8, we are going to put the number of fish itself because it duplicates. So we're going to put the number of fish there. So if we do that, Oh, then at the very end, we gotta do fish equals copy. So now if we run this should go much faster. And we're gonna get 9. Not quite right. Why is that not right? Oh, because this isn't adding. That should be like that. There we go. We got to add 1, not set it to be there. Is that still wrong? Oh, because I'm outputting the size of this, which is 9. Right, I want to instead output the sum of all of these. So let's just do this. This is going to be sum int sum equals 0. And we can actually go backwards because we can do the value set. And so we can just do then fish count. That's why we're getting 9, because we're outputting, yeah, that. Which, I still would have gotten wrong answers, but hey, you know. 566 is not correct, though. Because day 6 isn't, oh, the issue is day 6 isn't adding on. I see. We should be adding on, well, we're putting in. Okay, so day 6 is the weird one, right. Day 6 is the one that overlaps. Okay. Day 6 overlaps, we have to be careful. Well, why don't we just do this? I mean, not that it's needed for all of these. Plus, not bad, do equals. Not totally needed, but at least this way we'll guarantee that it won't override. And now we got the 3, oh, not quite. That's the wrong day. I was putting the wrong day in there. 3, 5, there we go, okay. Now we're good, so now we can ump this up to 256. Alright. Figured on the end. Say it was much better. Too bad that these are too small. We need to go to longs on this. Yeah, these need to all be longs. What's capital L? Sure. This is your, okay, and this is again long. Alright, try this again. Hopefully it won't wrap around this time. Still wrapping around? Why are we... Oh, because some isn't... Right, some needs to be a long. That one's probably the one that needed to be a long. There we go. Dump this in. There we go. Hey! Where did we get to? I'm curious. Second day, it should have been better. No, he fell further, all because my implementation was just bad enough, and I guess Java is not good enough. So it's probably just Java killing me there. But anyways, okay, well, this is better. All right. So there we go, day 6. So let me go through my solution here. Again, part 1 was solved different than it did for part 2, but this is a much better solution and will be a much faster solution. I mean, as you can see here, 3 milliseconds, and the other one timed out because it just took too long. But at any rate, so the TLDR of today's problem is that basically they're a bunch of fish. They kind of have internal timers that when the timer reaches 0, they reproduce and they duplicate themselves, and that timer gets reset. You probably read the problem again, but just know the fish have internal timers that count down and whatnot. So the way we do this is that we have all this fish in a hash map. So because all the fish have an integer timer in them, we can just put them in a map of the key being the days, I guess, or the timer number that they are at, and group them all together by the like timers, because again, they all tick the same. So if they have the same internal timer, they're going to effectively work the same in this problem. So we built up our map here of, again, the integer, the key being the timer, the long, the value in this being the number of fish at this timer. This first part just adds them into the list from the inputs. And then here's our for loop again. There's 2 days, but I might change this up to have both parts be on here for the final solution. But anyways, we have a kind of a main for loop here that goes for all the days. So this way it counts through all the days. I make a copy just because it's a little bit easier to do right now. But basically, we go through all of the keys in the hash map. Again, in Java, hash maps are not ordered. So you could do a way to go from 0 to 8, but I think it's a little weird with copying things over. I just didn't deal with that. I just felt like doing this was a little bit easier, but that would probably also make this easier to where you're adding in. You don't have to worry about this whole addition logic here, but at any rate, we go through all of the fish and all the timers. If the timer is greater than 0, we just simply decrement it. So if the timer is at 7, it goes to 6. If it's at 4, it goes to 3. And then we just copy that number of fish that was at that timer to the new timer. So all the fish that are at timer 6 go to 5 and all that. This is what it does that. It just does that copying over. Again, we have to do that special case here, which we'll get to in a second, to where if they're at timer 7 going to timer 6, it will actually get merged with all the fish that were at timer 0. Which is the second part here. If their timer is at 0, we move them to the new timer of 6, because that's what the internal timer gets set to after they reproduce. And then we add a corresponding duplicate number of fishes, because everyone makes one, so there's now double number of fishes in that time. We add those the new fish to 8, and they begin their time down, and this process keeps cycling going through. And at the very end, we just count up all the number of fish that there are at all the timers, and that is it. So, not too bad of a problem, not too bad of a day. Obviously, I was fast on the first part, but of course, my solution was not efficient enough to actually work for the second part. Too many fish, too many index values, doesn't work. I mean, my answer, how many fish were there in my answer? Only day 6, I had hundreds, millions, billions, trillion, quadrillion. I had like 1.5 quadrillion fish. Yeah, good luck having 1.5 quadrillion in list index. Not gonna work. But this way works much more efficient. And there we go. End of day 6. Hope you guys enjoy it. See you guys tomorrow. Okay, after note, I actually did end up going through and fixing up this logic here. Well, at first I fixed up to have both parts in my my solve here, to have both part 1 and part 2 work, and then I'll call this tick method. So I simplified the kind of tick logic much more to, instead of having to use that copy I was doing before, it does it all in the provided map. So this is how this logic works. Again, much more condensed, much better. I feel like I did enough work here. I wanted to just let you guys know I did simplify this much more, and that both parts are here. So yeah, sorry for it, but thanks for watching.